this last portion of the Interchapter A, we're going to be talking about some other nomenclature that goes in with our alkane naming. One of those things is going to be some other types of substituents that we can see other than just those alkyl groups. So one thing that's going to come into play are going to be our halogens. We refer to these as being haloalkanes anytime that alkane chain has a halogen associated with it. So remember, your halogens are there in column 7A or 17 on your periodic table. We're going to treat these halogens just like we would any other alkyl group. We're going to alphabetize them as the substituents. We're going to give them a locant. If we have more than one of them, we're going to use our Greek prefixes to tell you how many. So if you have fluorine as part of your compound, it is a fluoro group. Chlorine is a chloro group. Bromine is a bromo group. And iodine is an iodo group. And again, we would alphabetize them. Another substituent that's going to pop up is going to be nitro substituents. We can refer to these large molecules as being nitroalkanes. And again, we're going to treat this nitro group like we would any other alkyl group as well. The nitro group that you're going to be looking for is NO2, and we will use the name of nitro with it. And again, we would have a locant, and we would tell you how many of them we had if there was more than one. What you want to be careful with this nitro group is the structure associated with it. In the nitro group, that NO2 unit, it is the nitrogen that would be connected to the parent chain. So here with each one of these, our R unit would be here for the chain itself. That nitrogen is then doubly bound to one oxygen atom and singly bound to another oxygen atom. The nitrogen has a positive one formal charge. The singly bound oxygen has a negative one formal charge. So there is resonance structures associated with this nitro group. So you do want to be very, very careful that you have the correct atom, the nitrogen, bound to the parent chain. It is not one of the oxygens bound to the parent chain. So let's look at a couple of examples. Again, I would recommend pausing the video at this time and trying to name them yourself before seeing the answers. So for the first one, we would name this as 1-bromo, 2-methyl, cyclopropane. So cyclopropane for our 3-membered cyclo ring, bromines in the 1 position, so 1-bromo, and then 2-methyl in the 2nd position. The second example would be 2-methyl, 3-ethyl, 5-chlorohexane. So this would be following that IUPAC name of the most number of substituents. In this fashion, we would have 3 substituents on this structure. Another way that you could have named this, it does not follow all of our IUPAC rules. It follows more of the common nomenclature, but it would have been an acceptable name for me as well, would be 2-chloro-4-isopropyl hexane. So both of these would be acceptable for me because both of them are hexane chains. They have the longest parent chain. The second one, the one there in the darker color, is utilizing the isopropyl branch, which is more of that common nomenclature, which for me would be perfectly fine. I would accept either one of those on an exam. For the last one, the name would be 2-cyclopropyl, 4,5-dinitroheptane. So again, a 7-carbon chain. Lowest substituent is on the 2, which is the cyclopropyl group, and then we have 2 nitro groups on the 4 and the 5. Another thing that we want to be able to name are going to be our ethers. Remember, the ether functionality is an oxygen in between 2 carbon chains. So it's represented as our ROR functionality. Those 2 R groups can be the same or they can be different. And our nomenclature, I'm going to focus on those 2 R groups being different. The way we name these under our IUPAC nomenclature is that we find the longest R group, so whichever side that is, the right or the left, and that becomes our parent. We then label the OR group, what is left, as an alkoxy group. And we're going to replace the YL ending that we would for the alkyl group with oxy to represent the OR group instead of just being the R group. Ethers are very common with naming as well. The common naming for ether comes you see more often than you do the IUPAC naming. With common naming for ethers, you name both R groups as substituents, so you name both of them as alkyl branches, and then you follow it by the word ether. This one does have spaces. This is going to end up being 3 words under the common name, so you will have spaces in this nomenclature if you name ethers commonly. So you would name R group 1, you would name R group 2 with a space in between them, and then space and the word ether. You would alphabetize the 2 R groups, so it doesn't matter what's on the left, what's on the right, you would alphabetize the 2 R groups. So again, try both of these examples. I recommend pausing and trying before seeing what those answers are. So for number 1 here, the IUPAC naming would be ethoxycyclohexane. So we have named the larger side, which is the cyclohexane, as the parent, and then the ethyl group on the other side becomes the ethoxy, so that we know we have the O in between them. If you wanted to name this under the common nomenclature, so those common namings, this would be cyclohexyl, ethyl ether. And again, that would be 3 words. So we have named the branch on the right, we have named the branch on the left as substituents, and then the word ether, and we've just alphabetized those 2 names. So cyclohexyl, ethyl, ether. For the second one, this would be named as 1-chloro, 3-methoxy, cyclopentane. So if you find the ether, which is right here, what we have done is we have named the larger side, the side that is more complex with other branches, we have named that first. And then we have named the OR portion of it, the ether portion of it, as a branch as well. Notice it is just a substituent, so it acts like just a substituent. So we alphabetize it with the other substituent that is there, which is the chloro substituent. So C comes before M. It is a ring, so I have also numbered in alphabetical order. I have prioritized my alphabet. Since I could have numbered them either way, we prioritize based on alphabet.